Hello children, welcome to the class. For standard 9, the first lesson is rational and irrational numbers. You all have already studied about rational numbers in standard 8. We will have a quick revision. You should be very clear with this concept, that's important. We will start with natural numbers first. All of you know what are natural numbers. Natural numbers, or you say we call it as counting numbers as well. So which are those counting numbers? 1, 2, 3 and so on. These are known as natural numbers. You also know set of natural numbers is denoted by capital N, and since the natural numbers are countless, it's an infinite set. Now, addition of any two natural numbers is a natural number. But if you subtract a natural number from itself, the answer is not available in the set of natural numbers. Any number subtracted from itself gives the answer 0. So we need to extend this set of natural numbers and we get the set of whole numbers. So what is the set of whole numbers? We just need to add 0 to that, right? So the numbers, natural numbers including 0, are known as whole numbers. We denote this set by capital W. The smallest whole number is 0. And again, it is an infinite set. If we talk about whole numbers, addition of any two whole numbers is a whole number. And difference when we talk about, like when you do 3 minus 2, the answer is 1, which is of course a whole number. But when we talk about 2 minus 3, we do not have the satisfactory part for the set of whole numbers. We need to extend this set as well, and we come to the set of integers. So set of integers is what? This is your set of whole numbers, 0, 1, 2, etc. till infinite. And to this, for every natural numbers, you need to introduce its opposite. That is negative sign. That is but natural. You must have heard about the temperature also. Temperature goes below 0. So negative number do exist, and we have got lot many applications of that. So they are infinite on either ends. So, and we denote the set of integers either by I, we may denote them by Z as well. And the set of integers, how do you write it? Like this way. You all must know this. This concept should be very clear, very easy, very important, right? Now, we have learned about closure property. Let us check. Closure property means like if you add two integers with the answer is integer, the answer is yes. So this property gets satisfied. For addition, subtraction and multiplication of integers, the answer is integer and the property gets satisfied. The question comes when you divide any two integers. When you divide, say 4 divided by minus 2, the answer is minus 2, which is an integer. But the opposite is not true. Like if you do 2 divided by, say, minus 4, then the answer coming is not an integer. Hence, we need another extension of this, and that we call as rational numbers. This is the set of all numbers. We denote the rational number set by Q. It is a set of all x such that x is represented in the form p upon q, okay, where p and q are integers and q cannot be 0. You know that division by 0 is not permitted, hence we have to be very specific that q cannot be 0. So all the numbers which can be written in the form p upon q, you can call it as a fraction form, where p and q both are integers, are known as rational numbers. Okay, and like you can see the example of it. Say 1 upon 2, 3 upon 4. These are like in fractions you have studied. Then as it comes as integer, you may write it as 3 upon minus 4. And in previous class you have studied that this is correct, but it is not the standard way of writing a rational number. You always have to write it as minus 3 upon 5, etc. So these are rational numbers. And the addition, subtraction, multiplication and division, provided the divisor is not 0. All these are, if you add, subtract, multiply or divide any two rational numbers, the answer is going to be a rational number. Now let's understand this concept more clearly with the help of number line. Suppose this is the number line, right? And marking, you have to take care that the equal distance is there. This right now on this number line I have shown natural numbers. This arrow indicates that they are infinite. Now I have shown the set of whole numbers. This is set of integers, right? Both ends infinite it is. Now what you have to understand is that where are rational numbers? Are they all rational numbers? The answer is yes. Each one of them can be written into the form P upon Q. Like 3 you can write 3 upon 1, or minus 2 you can write minus 2 upon 1. So all integers are rational numbers. You know that all whole numbers are integers. All natural numbers are whole numbers. That means set of natural number, okay, is the subset of whole numbers. Whole number set is subset of integers, and integers subset of rational numbers. That means these set automatically are contained in that. And it's also clear that the set of rational number is an infinite set. Also you will come to know that between any two, these say integers, how many rational numbers will be there? Infinite. Like exactly between 1 and 2, if I have to introduce a rational number, I would introduce it like this way, right? Now in between, this is what? 1.5, say 3 upon 2. Now in between these two rational numbers, how many I can introduce? Infinitely infinite between these two. So in between 1 and 2 also infinite rational numbers exist. So we call this set as a dense set. In between 2, and not necessarily between integers, you might take two rational numbers as well here. And if you think about this, in between these two rational numbers particularly, and of course these are also the rational numbers, in between infinite rational numbers do exist. This concept should be clear to you all, right? And lastly, I will conclude here that all these rational numbers can be expressed into the form of a decimal. And the decimal, of course, you remember, they can be represented two ways. See, like 1 upon 4 is a rational number. If I put a decimal representation for that, the answer will be 0.25. What kind of decimal it is? Terminating decimal, you know it. And if I take instead 1 upon 3, you know the answer is 0.333 and so on. What kind of decimal representation it is? Recurring. You might write it as 0.3. On the top of that, if you give a dot, it means it is a recurring decimal. So I hope we have revised well and you all remember what the rational numbers are, how do we write them, and what kind of presentation we can have. Decimal presentation we may have, either it is terminating or it is recurring, right? Now as we spoke about the decimal representation of rational numbers, either it is terminating or it is recurring, one more interesting point is here. Let's discuss that. Your question here is, without actually dividing, state which of the following have terminating decimals. Here some rational numbers are given. So before we start, you should know the rule. What is the rule? If the denominator of a rational number can be expressed as a power of 2 or 5 or both. Like the denominator can be only 2 or some power of 2, 5 or some power of 5, or a power of the combination of 2, like 2 square into 5, something like that way, then the rational number will have terminating decimal exactly. So one by one let us discuss these cases. First fraction or rational number is 5 upon 6. So obviously by dividing you can check one thing, but since without dividing we are trying, just look at the denominator. Sometimes in the competitive examination you appear that time we have to do certain work very fast. That time these rules help you. Okay, so let's see. 6 can be factorized as 2 into 3. So 2 is okay, but this 3 tells us that this is not going to be a terminating decimal, right? 13 upon 25. 25 can be expressed as 5 square. So completely the power of 5. So it's going to be a terminating decimal. 7 obviously is going to be non-terminating decimal. 45. Now sometimes you have to see this full part. Okay. 18 upon 45. So you may think that 45 it will come as 9 into 5. Then 9 is some power of 3. But you cannot ignore that these numbers can be simplified by 9. So you have studied earlier. The fraction should always be in the simplest form, right? So you first simplify it and then go for the conclusion. So it will come as 9 2s are 18, 9 5s are 45. So 2 upon 5, again the power of 5 it is, so it's going to be a terminating decimal. 32 is again a power of 2, so this will also be a terminating decimal. Okay. As we have discussed that there can be infinite rational numbers between any two rational numbers, we have got one pattern of question to be solved. Let's see this part. Insert 3 rational numbers between 5 upon 9 and 8 upon 11. There are 2 methods for that. I'll show you. Now in between any two numbers, if you have to introduce, you already know that it can be the average, right? If you add any two numbers and if you divide it by 2, that will be the average of the two numbers. You have already studied the concept of average. An average of any two numbers would be, only two numbers I am talking, will be lying between the two numbers, right? So that is the first concept. 3 rationals I have to do. So I will be first introducing the first rational number. So the first rational, suppose if I take it as x. Okay. First or rather that one of the rational numbers we can have. So where will be the position of this x? It will be between 5 upon 9 and 8 upon 11. So following the concept of average, what it will be? Divided by 2. So I'll write it multiplied by half. The two numbers added divided by 2. So half and add. Since they are fractions, so I'm doing like that. 5 upon 9 plus 8 upon 11. Okay. How do I solve it? As keeping 1 upon 2 as it is. Find the LCM of 9 and 11. Co-prime numbers there. So LCM is 99. So 5 is multiplied by 11, 55 plus 8 9s are 72. Okay. So you get half, add it, 127 upon 99. Multiply 1 by 127, that is 127. 9 2s are 18, 19. This is our first number introduced. So how do you write it as? 5 upon 9, comma, 127 upon 198, comma, 8 upon 11. One number is being introduced here. 3 we have to find, so 2 more we have to introduce. how will we introduce now? You can introduce between 5 upon 9 and 127 upon 98, right? And okay, so let's go for that. So 5 upon 9, and I'll take it as say y. 127 upon 198. This will be the second rational we are going to have. Same procedure we'll be following. Y equals 1 upon 2. Bracket 5 upon 9 plus 127 upon 198. Keeping half as it is. Now LCM of 9 and 198 will be what? Definitely you will be able to understand what it is going to be. 198. And so 9 will be multiplied by what? If you are dividing it by 9, so you get here 22. So 5 multiplied by 22, 110 plus 127 as it is. So what's the rational number you have got? 1 upon 2. Okay, this will be 7, 3, 2 to 37 upon 198. No simplification possible. So 237 and 198 you need to multiply by 2. 8 to the 16, 19 to the 38, 39, 396. So now what we have is 5 upon, between 5 upon 9 and 127 upon 198, we have got 237 upon 396. Then our next number is 127 upon 198, and the last number is 8 upon 11. 2 we have already introduced here. These are the two numbers we have introduced. Third one, see how many options you have. Third one can be obtained here, number 1. Between these two, number 2. Between these two, number 3. Between these two, number 4. Right? In between this is already there. So anyway you can go for that. Suppose I wish to introduce it over here. So I will name it as Z. Z will be equal to what? 1 upon 2. Okay. 127 upon 198 plus 8 upon 11. On simplifying, I again get the LCM as 198, then 127 comes as it is, plus 11 by 18 times 1 is 8. 18. So 18 here, and 18 into 8, yes, 144. So what we have is 1 upon 2 into 11, 7. 271 upon 198. On multiplying you get 271 upon, yes, 396. So what is your final answer over here? 5 upon 9. Okay. Then you have introduced 237 upon 396. Then you have 127 upon 198. 271 upon 396. And last 8 upon 11. This is our first method, that is average. We have used average. Be very careful. Do remember which number is being introduced in between which two numbers, and you have to take care of the sequence as well. What is the second method? That let's see. Now let's see one more method, very interesting. Before I actually go for this, I'll just give you an example here. Suppose if I ask you, find the number in between say 3 and 5. What's your answer? 4, obviously correct. Now just see how we can get it. 3, I can write it as 3 upon 1, right? So any integer can be written as a fraction root. Plus, check 5 upon 1. Now add 3 plus 5, both numerators I am adding. What is the answer? 8. 1 plus 1, 2. What is the answer? 4. Right? So one thing is fixed, that 4 is a number lying between these two rationals. So same method you can use here also. So again, if I assume that there is a number x in between 5 upon 9 and 8 upon 11, then x can be taken as 5 plus 8, both numerators added, and 9 plus 11. That comes as 13 upon 20. So how you have got? A rational between 5 upon 9 and 8 upon 11 is 5 upon 9. In between 13 upon 20, 8 upon 11. And now it's so simple, I need not to show. How would you introduce another rational over here? 5 plus 13, 18 upon 20 plus 9, 29. So this could be 18 upon 29. And same way you can introduce here in between also. Right? 21 upon 31 will be the answer. This way you can go. Both the methods are there. Any one you can use. Now practice some more sums of this pattern. I know that you have studied in standard 8 as a revision part we have done. For standard 9 you need to remember complete. It is not the semester examination. So whatever you have studied right now, that full thing you need to study. We have got enough time, we are going to study it well. And one more suggestion I would like to give you all. You please subscribe this channel. So whenever the new video is ready, anytime you are free, the mobile is available or whatever sources you have at home to study yourself, you can study these videos. So when I conduct the online classes, in those lectures, we can discuss the doubts you have. Alright. So try solving, try to understand. This is a very easy lesson. We have simply revised our part. Okay. And also take care of yourself. Stay at home. Be safe. Okay. Thank you.